All right, let's get started. Today, we're going to pull back the curtain on one of the most powerful tools out there for modern strategy, probability. We're going to see how you can use it to make smarter, data-driven decisions. This quote really nails it. That whole idea of trying to predict one single definite future, yeah, that's pretty much out the window now. In today's world, strategy is all about understanding and managing a whole range of possibilities. And what's your primary tool for navigating this new world? You guessed it, it's probability. This is the language we use to talk about uncertainty. And getting fluent in it gives you a massive competitive edge. Okay, first up, we're talking about moving beyond just gut feel. We're shifting away from old school intuition and into a world where data really is king. And you can really see the massive shift right here. The old way was all about gut feel, which, let's be honest, is often just a fancy word for our own personal biases. But the new way? It's all about using data to map out all the possibilities. It's about preparing for a bunch of different scenarios instead of just betting the farm on one single outcome. So to even know which tools to grab from our toolbox, we've got to know what kind of situation we're in. If you're operating under certainty, well, everything is known. But let's be real, in business, that's rare. We're usually dealing with risk, where we know the odds, or uncertainty, where we don't even know that. Probability is our guide through both of those worlds. Okay, with that foundation in place, let's get into the core rules of probability. Think of these as the fundamental, non-negotiable rules of the game that make sure all of our analysis is solid. Rule number 1, and this one's super straightforward. Non-negativity. All it means is that a probability can't be a negative number. Sounds obvious, right? An event can have a 0 chance of happening or some positive chance, but it can never have a negative chance. It's a foundational piece of the puzzle. Next up, we have normalization. This one's also pretty intuitive. If you take every single possible thing that could ever happen in a situation and add up their individual probabilities, you have to get exactly 1. Not 0.99, not 1.01, exactly 1, or 100%. This just ensures we've accounted for the entire universe of outcomes. And the third big rule is additivity. This is for what we call mutually exclusive events. Fancy term, simple idea. It just means two things that can't happen at the same time. Like a single coin flip can't be both heads and tails. So the chance of getting either heads or tails, you just add the probabilities together. Simple as that. All right, we've got the basic rules down. Now for the really fun part, connecting business events. This is where we start to see how this all becomes incredibly practical. And this is where we get super practical with something called the addition rule. So let's say you want to know the odds that a customer buys your new running shoes or subscribes to your fitness app. You can't just add the two probabilities together, can you? Why not? Because you'd be counting the superfans who bought both things twice. This little formula here is just a way to make sure you subtract that overlap so you don't double count. And that leads us right into a really important distinction: independent versus dependent events. Now, some events are independent. One has no effect on the other. But in the real world, in business, things are almost always dependent. I mean, think about it. If your main supplier's factory has a major shutdown, what happens to the probability that your own production line grinds to a halt? It skyrockets, right? One event directly impacts the other. This brings us to one of my favorite topics, and it's one of the most dynamic ideas in all of strategy. It's about getting smarter over time. So let's talk about updating our beliefs with evidence. So this raises a really important question, right? How do we actually get smarter as new data comes in? How do we make sure we're not just stuck in our old ways of thinking, anchored to information that's completely out of date? Well, the answer is a beautiful little piece of math called Bayes' theorem. Now, it looks complicated, but the idea behind it is incredibly simple. It's a formula for updating what you thought you knew using new evidence to arrive at what you now know. It's literally the engine of learning, all captured in one elegant equation. And we can actually break this whole Bayesian process down into 4 really clear steps. First, you start with an initial idea, your prior belief. Then, you go out and see some new evidence. Step 3, you use that new data to update your original idea. And bam, step 4, you have a new, more refined belief, your posterior. It's just this constant, elegant loop of getting smarter. Okay, let's try a little thought experiment. This one is a classic, and it really messes with your intuition, so stick with me. Imagine a test that's 98% accurate. Super reliable, right? But the condition it's testing for is incredibly rare. Only 0.5% of people have it. Now you take the test and it comes back positive. So, how sure should you be that you actually have the condition? What does your gut tell you? 90%? 95%? The actual answer? A little under 20%. Seriously, isn't that wild? Your intuition was probably way off, right? This is the perfect example of what happens when we ignore the base rate. Because the condition is so rare, the tiny number of false positives from the giant pool of healthy people is actually bigger than the number of true positives from the tiny group of sick people. Bayes' theorem saves us from making this huge mental mistake. And just think about applying this to business, testing for rare market fraud or a tiny manufacturing defect. You can see how easy it would be to overreact. Okay, so let's shift gears and talk about some practical tools. Think of these as blueprints for uncertainty, standard models we can apply to common problems. First things first, we need to know what kind of data we're looking at. Is it a discrete variable? That's anything you can count in whole numbers, like the number of customer complaints you get in a day. Or is it a continuous variable? That's something you measure that can fall anywhere on a spectrum, like revenue growth, which could be 5.1%, 5.11%, and so on. And when we talk about continuous variables, there is one distribution that is the absolute king, the normal distribution. You've all seen this classic bell curve. And the reason it's so famous is that a ton of things in the real world, from financial returns to manufacturing specifications, tend to follow this exact pattern. So what makes this bell curve so special? Well, a few things. 1, it's perfectly symmetrical around the middle. 2, it follows that famous 68, 95, 99.7 rule, which is just a handy shortcut for knowing how much of your data falls close to the average. And 3, and this is a big one, the tails never actually touch the bottom line. And that's the math way of saying that super extreme black swan events are never truly impossible. They might be incredibly rare, but the chance is never zero. So let's pull all of this together and talk about the real goal here, the strategic edge. We've gone from the basic rules to dynamic learning models to powerful blueprints. This isn't just theory. It's about gaining a real-world advantage. And after all of this, it really boils down to one powerful question. Are you just reacting to the future as it happens, or are you proactively preparing for it? When you master probability, you're no longer just a passenger. You stop seeing risk as this scary thing to be avoided, and you start seeing it as a resource to be managed. You're in the driver's seat.